Welcome to this fourth part of 5-part video series. In the last video, we implemented a load balancer to handle thousands of concurrent requests. But see, we have a critical issue now. What if our user service slows down by 500 milliseconds? Or 5 would be too much. Even 1% of our requests fail with an internal server error status code 500. So logs are too noisy to detect that in the real time to see these trends. So this is where observability comes in. So in today's video, we are going to instrument our gateway to emit high fidelity telemetry using Prometheus metrics and visualize it possibly with Grafana. So let's jump right in. Let's start with installing this library. And this too. So now let's open our code editor. So now let's go to our file gateway.go. So what we need to do is we need to create some global variables to count our HTTP requests. We can have variable counter of type Prometheus. So this is the function we are going to use, new counter vector. So this function takes two arguments, counter option and an array of string. So these counter options have this type of option, and this option has various fields. We will only use name and help string. So yeah, where was it? New counter vector. So Prometheus dot new counter vector. So this takes two arguments. So first one will be Prometheus dot counter options. So counter option, sorry, in our counter options we have our name field. We can call it http counter request, or maybe http request counter, and help field to count all the http requests. And then we will have an array of strings. So I'll just explain you in a minute what does it do. So this strings will help us categorize our request based on the labels we provide. So I am going to provide three labels: methods, status code, and the user service, the service. So we can categorize it using status code, what all requests have a particular status code, or what all requests uh, have a get method or post method or etc. So I'll have a method and status and the service, the user service. Uh, Either we are hitting product service or a user service, so it categorizes the requests based on that. So this is it. And the other variable we can have the timer. This will be of type Prometheus some histogram function. Yeah, okay. Histogram vector. Yeah, new histogram vector. So we will have our this function for our timer, and this will help us plot the histogram based on the request, the time a particular request takes. So let's create that. Prometheus dot new histogram vector, and it will also have Prometheus histogram option. So Prometheus dot histogram option. Let's see what histogram options. It also has a name, help string, and bucket. So bucket defines the bucket into which observations are counted. In each element in the slice is the upper inclusive one of the bucket. So let's see. First we can have our name. So http request timer, and we can have help. We calculate the time taken by the request. Then we can have a bucket Prometheus dot bucket. So what does bucket do? We cannot store every request float value. It would be too expensive. It would be too expensive basically, so to store all these. So what we do, we create a buckets. Let's just say one request takes 0.1 millisecond, and so we will put in a bucket for we will put it in a bucket of 0.25 millisecond. Let's say bucket we have certain containers of 0. Request less than or equal to 0.25 second, from 5 to 10 milliseconds, and so on. So we will have these kind of buckets. So if a request fits in that bucket, we increase the counter of that bucket by 1. So we use that, and we'll have to again provide an array of string. So we will have a method in this to see, to categorize it by method, and to categorize it with service. I hope you understand why we use this bucket. So the buckets are the default histogram bucket. The default buckets are tailored to broadly measure the response time of a network service. Most likely, however, you will be required to define buckets. So we will use this only. So it is basically an array of float. So after creating this, we also need to initialize it. So function init and Prometheus dot must register and pass our counter, and Prometheus dot must register pass our timer. So this is to register our variables when this init function starts even before the main. So it basically registers our variable to start counting whenever our server is ready to handle the request. Now we need to in order to capture this status method, we have no way of reading from the response. So once the service, our service or user service or our product service writes into our response writer, we cannot read our status code from it once the response has been written. So we need to create a wrapper to trap this status so that we can send this to our Prometheus. So this is how we will do it. We will create a type struct type status recorder. Status recorder, it would be of type struct. It will have an http.ResponseWriter interface and a status code of type int. So I'll explain you what will happen. So we need to create a function to override the write header method. So we will have this on as status recorder, and this will be called exactly the write header method, which takes a code of type int, and we will capture it the s, let's just say recorder. So recorder dot status code will be equal to the code, and the recorder dot is our response writer dot write header. This will have the code. So let me show you what we are doing. So as we know, the response writer has a write header method. See here. So write header method takes a status code which is of type int. So we are capturing our status code which is returned by the service. So there's no way of directly reading from the response. Once the response has been written, there's no way we can read the status code from it. So we are not actually sending our true response writer to it. We are creating this wrapper around it so that whenever a response is written, it actually calls this write header method, this write header function, which will secretly store this code in our status code and then call the actual response writer write header method. So this is way of intercepting in between the status code. So this will be stored, and the write header method, the actual write header method will then be called. So this is a very clever trick to capture the status once the response has been written. So let's create our this middleware, metric middleware function. This will also be attached to this uh, gateway, and it will be called metrics middleware. And it will also take our next function http.handler, and it will also return http handler and return http.handle func, which will take a function http.ResponseWriter and request http.request. So now we need to start our start time equals to time.now, and now we need to create our recorder of type status recorder, and our response writer will be W, and let's give some random status code. Status code will be http.status. Okay. It would be overwritten after the next handler is called. When the response comes back, when the response is written, the status code will be overwritten. So don't worry about that. It will always have the status. Okay. So now we need to identify the service name. So let's call the service name to be some empty string. Let's call find service. It had gateway now. Gateway dot find service. Yes. So gateway dot find service provide our request, and what does it return? It returns a service. Service, and if service if service is not null, then we can call our service name will be equal to service dot name. Uh, so yeah, we identified our service, and now I think we can call our next method, service dot maybe proxy dot next. So we service name. Now let's call next dot service http. We provide our recorder instead of our W response writer. We provide our recorder and our requests. Once this is done, now we can have our what function, what variable we had. We had counter dot with label values. Sorry, counter dot with label values, and timer dot with label values. Sorry, timer dot and before that we need to calculate our duration. Time dot since our start time, and to provide to our counter with label values. What were our label values? Label values were, let me see, what was the label values? Method, status, and service. So method, status, and service. So our method will be recorder recorder dot status code. Just hold on a second. So we can have this duration in seconds and counter with label values. First, our first label values were first was method, then status, then service. So first would be method. It will be all about method. And then it was status fnt dot printf and percentage d. It will be recorder dot status code. And then was sorry method status code, and then it was service, so service name. And with timer also we had timer, we had first we had method and then we had service. Service. So first we had method, then we had service. So first we had our dot method, and then we had service name. So we will count observe and then duration, and we will have increment in this increment. So this is it for our middleware, metrics middleware. So we will start counting when we get the request from the user. We start the timer. Then we spoof our way through the response writer. Then we find the service name, what service it the request is sent to use this in our counter and timer variables respectively, and the duration, the time it took to process the request and send the response back to the user. So yeah, this is our metrics middleware. Now, like we registered our auth API key, so we need to register our register our metrics, and we have gateway dot metrics middleware. So this is where we register our middleware, and then in the main function we can have mux dot handle slash metrics and call Prometheus, and have this from http dot handler. So I guess this is it, and now we need to change our config. Let's config.yaml, and now under middleware we can have auth API key. First we need to have metrics, and then we need to have auth API key. I think we are done here. Uh, user service, users, and metrics and auth API key. So we add metrics before the auth API key because we need to start it before we serve any request. So here we created this new file called Prometheus.yaml, and this configuration, copy this configuration. This will scrape every 2 seconds, and our target is the 8080 because our gateway is running on port 8080. And I have changed this config.yaml. Now middleware is metrics, only metrics, because due to this loop, I couldn't add the API authentication, so I removed the API authentication and added just the metric to test and the gateway.go. So there's nothing new here. That's the already. So yeah, there's nothing new here. And this is the command to loop every 0.1 second and send a request to this product. So it shows it hit our product, forwarding the request of product. Let me see. Yes. Change directory, backend. AT82 config dot. Yeah, AT82 is of product. So it sometimes returns 200, sometimes it returns 0. So this is our Grafana, and yeah, we did this query http request counter because we named our service http request counter, and our service you can see here is product service and status is 200, and the method is get, and instance and jobs come from the Prometheus configuration file. So this is the request, as you can see. This has status 200, and you can see different data points of successfully hitting the backend. So yeah, this is it. This is the metric. You can see how to set up this in Docker, the Prometheus and Grafana. I have provided you the YAML file of Prometheus. This is it, and same I will be committing to my GitHub. So As you can see, it is fitting now. And our Prometheus dashboard is displaying the metrics. So yeah, this is it. Thank you for watching this video. And in the last video, we will be polishing this and making it more robust. And maybe we add rate limiting and circuit breaking to complete this gateway. So yeah, stay tuned for that. Bye bye.